There we go. We can see your slide deck now.
Great. Yeah. So hi all. This is the agenda for today's session. We are going to go through what is Azure ML or Auto ML overall, how to get the subscription, and what is the machine learning lifecycle looks like. And we'll go and do a deep dive on the components which Microsoft is offering through Azure ML services. We'll do a quick demo on the basic regression and classification model, which is the case study by Microsoft provided the data sets publicly for that, so it will be easier to go through it. And at the last, we'll see how to evaluate the models, or how to deploy and maintain the ML solution. Yeah. So to start with, let's talk about first the traditional machine learning development, right? When we start developing an ML model, it's it's resource intensive, it's time consuming, it requires programming expertise, and it's not too quick to do POCs and showcase the benefits to the business right away. And then you need to develop a lot of models, compare their outputs, and then identify the best fit for your scenario. So overall, if we see the ML development so far, it takes a lot of turnaround time to reach to the conclusion. And in general business scenarios, we don't have that much time to prove that in this particular forecasting model, or uh, the ML model, uh, we don't have that much patience with business to showcase the, the results. Okay, so what AutoML brings here? So AutoML is nothing but the process of automating the time-consuming and iterative tasks which we do in the machine learning model development. Now think about a basic ETL tool, right? And if you go back 15 years or 20 years, there were no ETL tools, and people used to write the code in the database layer or through scripts, and we used to do the ETL in that way. But now, if you think about the ETL tools today, right? You take SAP Data Services, SSIS, or now ADF, right? So it became a drag and drop functionality, and you can do each and everything which is possible, or which is meant as an ETL process, which helped developers to cut short the development time, and at the same time easy to maintain and operate on. So similarly here, if we see the auto ML tools right now, we see a bunch of players in the market. First one is definitely Microsoft Azure ML. Cloud is having their auto ML tool. There is another one called Data Robot, and I have given a couple of links here to see and you know evaluate basically what are all the tools available in the market. Yeah. So I would say within a year or two, it will be a very mature area where it would look like an ETL tool. Right now, it's starting. Microsoft is providing a very good basic basic things to operate in Azure ML Studio. Okay, so now what is Azure ML? Azure ML is basically a Azure service provided through Azure Cloud, and where you can go develop, train, deploy, and automate your machine learning models. What are all the features here, right? So features are you can have zero code to low code, basically, to for your development purposes. You can have integration with Python and R, which means you can write your own code as well, where automated ML or drag and drop functionality doesn't suffice your needs. Similarly, you can develop from classical machine learning models to deep learning, and obviously supervised or unsupervised learning models you can create here. It has interoperability with a lot of open source tools like PyTorch, TensorFlow, scikit-learn, and rlib. Yeah, so how we can get it started with Azure machine learning, and how we can try a hand on it, right? So Microsoft provides a very good way of starting or learning the development, open for people who are interested in it. So here I have given a link for Azure subscription. If we go on this link, you can start a free trial. It requires you to provide your credit card for validation, and then it's a pay as you go. So basically, when you subscribe for the free trial, it provides you 1 month of subscription and $200 of credit. And believe me, that is sufficient for for a month of trial and learning and trying out the things out there. And the best part is there is no automatic charges. You can set up as you use. If you see the services provided here, right, and the cost involved in it. Uh, if you see the storage, it's like 2 cents per GB per month. If you go for the experimentation, it's like $1 per hour of experimentation runtime. Deployment is around zero point 0.1 to zero point 0.5 dollar per thousand API calls. So yeah, so cost wise, if you see, it's the best one, I would say. And here I have given a link for Azure price calculator, where you can go and put your configuration for storage, experimentation, or deployment, which you think you would be going to use either in the personal setup or in the professional setup. You can basically pre-calculate what is going to be your cost for using this service. Right. Yeah. So let's talk about the machine learning lifecycle. How do we start with developing a ML model, and how the whole journey goes about it. So the first thing is definitely you get some business requirement on your forecast, or evaluating something to see the future, right? And based on that need, basically you a data scientist collects the data, gathers the data. Then you need to pre-process that data, cleans it, go through the ETL cycles to make it perfect for your model, your ML model, right? And then after cleansing and collecting the data, you you kind of go and understand what are all the attributes you have in the data, right? And what is your ultimate goal. Based on that, you basically choose a couple of models, develop the code for it, then you know you run that code and train the models, right? So to train the models, then again you need two different set of uh, data. One is for your training, and one for evaluating that the trained models which you have, are they working fine or not. So based on this iterative cycle, then you test the models and come to a point where you need to now evaluate the different models which you built, right? And that evaluation is based on multiple factors, and whatever is your business scenario. Based on that, you evaluate and find the best model for that scenario, and then you go ahead and deploy the model, and after that you start using it. So if you see the overall life cycle of machine learning development, it is a bit time consuming, and involves a lot of pre processing. It's not as simple as you go ahead and just code the ML model, and boom, you're ready with your forecasting, or whatever is the business scenario. Okay, so let's get started with the deep dive. I'll go and showcase what components we have in Azure Portal and Azure Machine Learning service. So here, if you see, right, to get started, on a basic development, you would require a couple of basic resources with you. First one is workspace. You need to create a workspace in Azure, which is nothing but the top level resource for Azure machine learning services. Then you need to create a resource group, which is nothing but a logical collection of all your resources like storage, virtual machines, network, and key vault and things like that. So it's nothing but a kind of folder where you collect all your resources. Then comes the compute. So basically, you set up your compute based on whatever is the need or whatever is the size of your data. And then comes data stores, which you are going to use as source. So let's get started, and I'll go through the live demo on that. Yeah, so this is the Microsoft Azure portal. So once you subscribe, you can go here, and this is the home page for it, uh, where you can get started, create a resource. So we want to create a machine learning resource. So with machine learning, it will give you a window for that, and select create. Yeah. So here we are going to create the workspace and the resource group to get it started with. Here, if you see, I have to select the Azure subscription, and this is the free trial version which I created subscription on. Right. Yeah. So here I can create a resource group, or I can give the already created one. But let's create. Right. So here I'm creating a new resource group. This is the workspace name, and I need to select basically what region my workspace and resource group is going to be created. So selecting the region basically depends on uh, where exactly you're going to run the services, right? So based on that, you can select your region, and it makes a difference when you are planning to offload the data from cloud to on-premise. That makes a huge difference, because if your region of this cloud or your services is near to your on-premises infrastructure, that makes a difference. Onloading the data on cloud doesn't matter if your region is different, but if you're planning to offload the data at the end from cloud to on-premise, it makes a huge difference.
I'm sorry, can we ask questions now or should we wait to the end?
Sure.
Have you found that all the various types of like, does the region need to be the same with for the various types of VMs that you may have backing this?
Yeah, it's not necessary. Again, your region should not. I mean, it's not necessary that you have for all the VMs same region. It depends on the usage you are going to have. Like I said, at the end, if everything is going to happen in cloud, right, then it doesn't make a lot of difference. But at the end, let's say you're you're going to utilize this data for, let's say, your data warehousing uh, mm, needs, right? After aggregation, one flow is going to the machine learning model, and one flow is going offloading from cloud to on-premise. Then you need to be, bit aware of where is my on-premise infrastructure, and accordingly you'd select the region. Does that answer your question?
Yeah, thank you.
Okay, great. So workspace edition, we have two options here: basic and enterprise. Definitely, we need to select enterprise to uh, make uh, to take advantage of all the services provided here. So I'll select create, and let's create workspace and a resource group. It would take around a minute to turn it around, and boom, it will be uh, you know there with all the resources. Yeah, so turn this is basically right now in the beta version. If you see right, both the services which we have for ML, it's in beta version. So I have not directly used it in a production like environment where the models are deployed. I would say it's in the POC stages where trying hands out and see how does it turn around. Yeah. So by the time it deploys, let me just show the how the Azure machine learning homepage looks like. Yeah. So this is the machine learning studio, and as I was talking about, right, this is in preview stage by Microsoft itself, which means it's in kind of beta stage, or given to the public for trying out the hands. There are uh, standard SLAs, or I would say service level agreements are still not defined from the support standpoint because it's in the preview mode. Okay, so the deployment is done, and we are ready with all our resource group and the workspace. It takes you to this window, and from there you can basically launch machine learning studio. Okay. Yeah, so here we go. Here, if you see, this is our workspace, and we are at the home page of machine learning. Now we got basically three areas where we can go and develop the things. First is notebooks. You can go and create the Python scripts, write your code, and create your models. Second is automated ML. Right here, you don't need to do anything. It's code free option where you just provide your source data and provide the 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 model you want to choose, or the problem which you want to solve, let's say for classification or regression or time series forecasting, right? You need to just input the data set, and then this functionality of automated ML reads your input and internally runs so many different combination of the algorithms and provides you the output with with different models which it tried at the runtime, and it gives the metrics for each of the algorithms which it tried out, and also gives you the, the best model based on the accuracy and other factors. So option number second, where you can develop things, are write your ML model, is automated ML, and this is completely code free, and you don't do anything. You just provide the data source, and you select basically what kind of a problem you are trying to solve. And third option is designer, which is a drag and drop interface, and where you can go and uh, do a lot of things, which is like, cleansing your data, validating your data, pre-processing your data, and then selecting the different models which are provided here. And based on that, you can create your own model and deploy it. Yeah, so let's go through uh, through each of the component one by one. I'll just walk through what are the the options available or the features available in the designer. Okay, so designer is again drag and drop functionality where you can go and create your own model. Yeah, so if you see this particular page, we are provided with all the modules, and if you see this pan, you have features to select like data input and output. You can enter the data manually. You can export and import data as web service. Then you got options for your data transformations. You can add columns, remove columns, join, do data sets. You can split data. You can convert data. You can normalize the data, partition the data, remove duplicates, a kind of ETL type of functionality to pre-process the data and cleanse the data. So for all those purposes, you can utilize all the modules provided within data transformation. Next is feature selection. Feature selection basically provides you capability to select the features from your input data set, right? Sometimes we are not sure what should be your attributes which you should give to the ML model to predict better. In that scenario, this feature can help us a lot, right? Because it can read through your input data set, and it can select the best attributes which you have within the data set, and kind of recommend you that this is the ranking of the attributes which we have in terms of predicting the results better. The next one, if you see, we have a statistical function which provides you capability about summarizing your data set. So summarizing the data set from the statistical standpoint, if you see here, is basically it will just read through your data set. It will calculate different stats around it to give you better picture about what your input data set looks like, your mean, mod, median, and different stats like that. Then next module, if we see, right, it provides a set of machine learning algorithms from which you can choose and uh, pick for your model. So there are total 18 algorithms right now available for usage. For regression, we have total 6 algorithms. For solving a clustering problem, we have one k-means clustering. And for classification problem, we have around, we have total 11 models, 11 algorithms available for the usage. Yeah, similarly for training your model, you have PyTorch, you have train clustering and train model modules here from which you can choose and utilize in your model basically. So these modules are going to be used for uh, you know training your model, and once your model is trained, then you can use it for evaluating and deploying the best model selected. Similarly, here we have few modules available for scoring and evaluation, by using which you can score your model and evaluate at the end. You can use Python language to create and run your own script. Similarly, for R, Then we are given with few modules around text analytics and also around the vision computing, which basically deals with analytics around, or I would say, data mining or text mining, and also around if you're dealing with let's say images. So there are around four or five, yeah, total six transformations are provided for handling the images. Then there are recommendation models provided by using which you can recommend. And then at the last you have anomaly detection and the web services. So it you can basically create endpoints out of your ML model, which can be used as a then you can have endpoints as web service input or web service output. Yeah, so I'd like to start with a demo here, a very basic regression problem, uh, to see how these modules work, or how to arrange these modules for solving a very basic regression problem in machine learning. So before that, I would like to go and create a compute cluster. So let's create a compute cluster. Yeah. So here, if you see, in the basic subscription, you would be you'll be provided with basic options for the virtual machines and the respective quota, basically. So you can select the the general purpose one, because in normal development, or trying hands out, you don't need a very heavy virtual machine to try out with. Yeah, so it's not Databricks, it's the virtual machine. Okay, so here you can select the minimum number of nodes and the maximum number of nodes which you would like to utilize for your compute, and then ideal seconds before it scales down. Okay, so I'm not left with any other, I can scale up only to up to one nodes. I'm not having sufficient quota to utilize with my subscription. So let's go ahead and do it with one node.
Yeah, that's where my question was coming in, because as I've done this before, it really depends on your quota limits per region.
Right.
You can ask them to increase it, and then I usually leave 0 as the minimum in my node group, so that way when it's not using them,
Yep.
you're not getting charged.
That's right. So yeah, in while creating your compute clusters, definitely you should choose 0 as your minimum, and maximum depends on the availability of quota. Uh, yeah. So if you see, there was an option to scale down. So after 120 seconds, if you're not using that cluster at all, after 120 seconds, it will scale it down, and you will not be charged for the usage because there is no usage happening, right? and no nodes are at work at that point of time. And in the free subscription also, this quota limit is a bit uh, mm, impacted because of the COVID situation. They want to give preference to you know the infrastructure where it is required for health and emergency services and things like that. So they have put together a clear message over here saying that it might affect your quota limits. Okay, yeah. So let's get started with regression demo. Okay, so there are some sample data sets available by Microsoft publicly, and very basic regression problem if you see is to predict the automobile price. So let's start with that. So let's select your input data or the source data. So this is the automobile price data. I selected that, and as per the case study or use case given, right, we'll try to cleanse the data and do some transformations around that, the basic ones, to take it forward. So I'm selecting this transformation where you can, basically choose or cut short your overall column. So let's say if I don't want to select all the columns or take them forward for the transformation, then I can. Yeah, so you can basically visualize your data set. uh, it, when you drag and drop, you can see how many rows and columns of data you have, what is there for each of the column. You'll be able to see the stats here, basically mean, mode, median, max, standard deviation, unique values, and stats like that. Yeah, so here basically what I'm doing is I don't want normalized losses column to take forward. That's why I'm just removing it from my data set. Let's go and cleanse. So yeah, so here I'm cleansing my data set. So if I if I'm getting the missing values basically in my data set, then I'm setting the minimum and maximum value, or the ratio basically, which I would allow my different columns or attributes to have. And if it is crosses that tolerance limit, then I would like to ignore that data, that particular row. So if you see the cleaning mode, you can either replace with other values like mean, mode, median, or you can remove the entire row if you are having the missing values in the data. Okay, so after doing the basic, cleansing our data, let's split the data for training and running the model. Yeah, so here I'd like to, split the data in such a way that 70% is used for my training purposes and 30% is used to, basically run the model and then evaluate it. Yeah, so here I'm just setting a property, fraction of rows, which should go to the first output, which is 70%. And, this particular module will just simply, split the data randomly. 70% will go in output one, 30% will go in output two. Okay, so after splitting the data, let's you know train the model. Okay, now so to train the model, I need data and I need the model which I want to use for training it, right? So 70% of data I'm getting from output one, which I would like to give to the model, and at the same time I need to choose a algorithm by using which I would like to train this model. So let's select linear regression. Okay, so my training model is having linear regression as an algorithm, and I'm getting 70% of data to basically train it. Okay, so after training the model, I would like to score it. Right. So for scoring whatever model I have trained, okay. So the model which I would like to train, what exactly we are trying to predict? We are trying to predict the price of the automobile. Right? So this is the column which you give as an attribute to your train model module. And at the end, then you would like to evaluate the model. Yeah, so at an overall level, if you see, right, first we selected our data set, then we did a bit of cleansing of data by removing a column, cleaning the missing data records from from the data set. Then we did a split of data into 70-30 percent ratio, right? So 70% of the data we are giving for training the model, and 30% of data we are giving to another thread for scoring the model, right? When we are training the model, we selected linear regression, which is working as a component of training module at the runtime. And if we see score model, we are getting the output from trained model, and at the same time we are getting 30% of input data, which is raw data. And now this is score model module is going to run on that 30% of data to see how it behaves. And at the end, then basically we are evaluating how the model works. So this is how basically in the designer you can drag and drop in, create a model. After creating, you can submit it for the run. So here you need to simply select the compute target, and you're good to go and submit the run. And when you submit the run, you need to give it a name, or you can give the existing name. And this run is called experiment because you're running an uh, ML model, and it would work as an experiment for you. So this is called an experiment. Okay, so here I have submitted the run for this model, and I'll be able to see how this progresses. I'll be able to track what is my progress and where I am currently on. So by the time it runs, it's definitely going to take time. So let me show you the model. I mean the same use case which I have already ran, and let me take you through the results basically. Yeah, so this is the exactly same model which we have just developed, but this is already executed experiment for the same. Let me take you through how does it look like. So this is our source, right? If you visualize the data, we had 205 rows and 26 columns as an input, and at the same time here you can basically visualize what are all the stats for each of the column you have in the data set. And our final goal is to predict the price uh, given all these attributes in the data set, right? What is the make of the vehicle, what is the fuel type, aspiration, number of doors, body style, and all all related attributes basically. And based on that, basically you are trying to predict the price of the vehicle. Yeah. So second step was to basically select columns in the data set. Here if you see and visualize your data, you are having 205 rows and 25 columns. So one column is reduced here because we trimmed it down. If you see the output from clean missing data module and visualize, yeah, so there is no row which qualifies for the tolerance which we set as a missing value. So we don't have any missing values across any records for these columns, and that's why there is no row removed from the data set. Now if you see the split data output, here if you visualize the output of this particular module, you'll see two data sets over here. One is having 144 rows and other one 61. So 70 to 30% ratio. It randomly divided this particular data set. Yeah, so train model basically you can register for it, or you can view the output of the model. It provides you the path within your Azure ML, where you can go and check how the model is created, and at the same time you can register it as well. If we go to the score model module and try to visualize the data, so it gives you a column called score labels, where basically it predicted the price of vehicle for those 61 records, which was 30% of your input data set, which was not given for training and utilized for running the trained model. So basically for those 61 rows, if you see here, you have the scored label, and it provides you the price, the actual price which was given in the data set, and the predicted price which is provided corresponding to it. And this this is what we wanted to predict through this regression model. And again, each column provides you basic stats around it to glance through. And the final step, if we go and visualize the final output, it basically gives your evaluation of the model, and basically you know the five factors based on which you can see how your model is working out. So any questions or queries here on how we can create a model, and how you can browse through the data sets and go from step one to the final step to see how things are working out for you. Yeah. Yeah. So basically, you and then we'll be given this five factors about the evaluation of the model, right? So first one is your mean absolute error. Mean absolute error is basically your difference between the predicted value and the actual value. So here, if you see the model which is scored, right? Now this is the price. Okay, so the data set which you already have, right? That is the actual data which you got from the history, right? Which means these were the actual price of selling your car, right? And this the scored, or the forecasted or the predicted value which we got through this particular model, right? So this is your actual value, and this is the predicted value. Now, mean absolute error, this is the average between your predicted value and the actual value, right? Which is a clear indication of uh, how your model is working out. If the predicted value versus actual value gap is too much, which means definitely your model is not so accurate, right? Second stat here is root mean squared error, which is again, but square root of the average values or the squared errors which you predicted on the test data set. So mathematically, if you look at it, right, these are nothing but the squared root of the average squared errors of predicted value which you had from the data set. again, the third and fourth, if you see, right, it's relative absolute error and the relative squared error. Again, this is the relative absolute error. If you see, this is the average of absolute errors related to the difference between actual values and the average of all actual values. So basically, if these factors or these error values are too huge, it's not a good model, basically. Yeah. At the same time, if we go back, you know, you can see how your progress is going on. What are all the tasks you completed, and what are all the tasks are queued up for the processing. So here it gives you basically live view of what is happening at the runtime.
So if you wanted to, you could have also put in some modules in there around like transforming your data a bit more, if should you needed to.
I mean, during the run you're talking about?
I mean, not during the run, but like earlier when you were designing it, there was additional modules for like transformation of data and things like that. That's where you would do that here.
Yes, yes, yep. So you can basically choose and pick anything which is required for either for your pre-processing, cleansing of data, or you know like for scoring the model or model selection, algorithm selection. All the tasks you can basically choose in permutation combination to come up with a model. And it's not necessary that for this linear regression problem, this what we did right now is exactly going to be the best model, right? You might want to test out another algorithm for regression. So we just selected the linear regression module here, right, to train the model and then score the model. But for solving the regression problem itself, you have multiple options or multiple algorithms available, like this. So whatever fits to the scenario and whatever fits to your data set, is that something which you come to a conclusion after trying out, or comparing a couple of algorithms which you have for regression or for classification?
So where do we go again to see the model?
You mean to you meant the run of the model?
No, I want to see what model it created. It's a linear regression, so it should be, like coefficients for each of the, columns that you chose.
Yeah, you can go in and see them. You can also use your own custom models as well if you want.
So it'll show you like price equals some coefficient times like miles per gallon plus you'll be able to see all those coefficients to see, which ones were more important in the model.
Sorry, I didn't catch you. Can you please come again?
Like so you can go and see exactly what coefficient went with what column in the
Uh-huh.
model. Where does it show you that?
From your input data set.
Yeah.
Yeah, I think I need to check on that. I'm really not sure where you can get that option to see that.
I think if you go over to, can you go over to the models on the far left?
On this window.
Uh, yeah, the window you're sharing, the far left, there's a models icon. Like right now, we're on the designer.
Yeah, so here basically you get the model which you publish basically. So once you're done with the model, right? Once you publish it, then it comes
Yeah,
as an option there.
on the very far left there, there's a tab for like look, keep going all the way till you hit the end of your screen. Left. There you go. There's a models there.
Yeah, no, it's the same thing. Yeah.
Okay.
So yeah, if you see the the runs which I already completed, so in models it would list all the models which I have published earlier. So for the same regression model, if you see here,
Yeah. So if you go in here, you should be
I
able to
have
see the artifacts and then see the actual model, and you can download it if you want.
yeah. So if you see, I mean, in that view also in the run, if you select what is the path of your model where it is saved, you can copy that, and this is exactly the same exact path where it keeps your artifacts after the run.
Did that answer your question that you were asking?
Yes. Thank you.
Okay, so this is about how basically we can use the basic features of the designer. Similarly, on the auto ML part, if we want to utilize this, we can basically start with creating an automated ML run. And as I said previously, here you don't have drag and drop functionality here. You provide the data set, and then Azure ML services basically goes through the permutation combination of different models, and then comes up with the best model for you. And at the same time, it provides you the same kind of uh, stats which we have seen here in the regression model for you to evaluate and see what model is best. So I'll do a quick demo on the steps which you basically can follow for running a classification model. Yeah. So first steps is definitely choosing your data set. So this is a bank related data set where we are going to basically run through the classification and try to predict if a client will subscribe to a fixed term deposit for the financial institution or not. So again, the basic classification problem where you are going to classify the data that a record for a particular client uh, is going to say yes or no for the subscription. So the first step is basically to just go and configure your data source. And here again, I'll be using the Azure Blob storage by default, which is given, and then I can choose the data set. Yeah, basic, you know, the file formatting options we can choose from here. It's delimited, comma delimited, column headers. All files have same headers. I don't want to skip any rows. And according to the use case, basically, day of the week doesn't contribute as an attribute to this model at all. So just for showing how you can do the data cleansing or data modification here, uh, you have option here as well, right? To select your type, to exclude the columns and things like that. Yeah, so here basically my first step is done. I'm done with well, selecting the data set. And yeah, and now I can just give it for the run. Yeah, so I need to basically select the target column which I want to predict basically out of this experiment or out of this run. Right? So there is a column. These are the columns basically which are present in the data set which we have. These are all the attributes around the client which we have, and the final column which we have is called y. That is the value which we are trying to predict here. So target column which we want to predict is y, which is selected here, and then I can select the compute cluster which has been created. Yeah, again, as I said, there are three options to select or solve a problem through this automated ML feature: classification, regression, and time series forecasting. So uh, as we select classification and just say finish. Okay, so basically so far we have just given our data set. We selected what kind of problem we want to solve, and we have given it for run. And in this window it has a couple of options uh, to view continuously. So in the models view, basically uh, it's going to throw all the runs which is it is going through, and as we proceed and as it runs, it will spit out a lot of runs which it is doing by selecting the algorithm and also providing the accuracy of the run and uh, you know the same stats which we have seen for other model. And at the end, basically, it will show you what was the best run and what was the best accuracy out of all this all these algorithms and runs which you had for this model. So just to give a glimpse here. Yeah, so this experiment which I'm showing right now is already executed previously, and yeah, so this was the last one I had with the same use case which we have gone through. So here, if you see, it gives you stats about how much time it took, the duration, and it at the summary level it provides you what is your best algorithm, what was the accuracy for it, what was the sampling, and it gives the run stats. And if we go and see the data guardrails, which provides a bit more understanding on the input data set, you can see for this particular data set, it said class balancing detection, where it might qualify the input data set as underfitting or overfitting for the model which you're running. So basically, the stats are the comments about your data set. And in the models, if you go, it gives you all the runs for different algorithms which it had. And you can see at the top it provides you that particular algorithm which is the highest in accuracy. Yeah, if you basically select that particular the best accuracy model, then again it would give you the stats around it basically.
Have you compared Azure, Azure ML to any of the other automated machine learning tools like Data Robot?
Yeah, so I don't have any hard comparison in terms of cost or in terms of uh, the options available or the features available in both. But here I have given a link where at least it lists down all the ML tools which are right now available in the market, and what stage it is in, when it was launched, what is the maturity of it, and things like that. But a hard comparison in terms of either performance, cost, and the features, I don't have with me.
Yeah, sounds fair enough. It's good.
Yeah. So here, if we see our run, it's still preparing for it, and as soon as it starts running, right, it starts uh, spitting out the models which it is running currently and which are completed. So you'll start seeing the runs popping up over here, and then at the runtime, basically you can see how things are going. Yeah. So as here we selected the best model, right? It provides you the overall summary of how the best model worked, and which feature was important for that particular model, and the ratios around that. Yeah, so basically we got three options here in the ML Studio. One is you can go and code your own in notebooks. Another is a designer, which is drag and drop. You can select the data transformation modules. You can select the limited available models which are provided by Microsoft so far, and score, train, evaluate your model. And the last one is automated ML, where you're not even dragging and dropping the features. You are just providing the input. You are just selecting what kind of problem you want to solve, and or what kind of prediction you want to have through classification, regression, or time series forecasting. It basically spins around the permutations of algorithms available, and gives you a comparison of those models as well to choose from. And other features, or I would say supporting capabilities we have here is you can create endpoints to be used as web services. Definitely compute data stores and data labeling is required to get started. This is your basic infrastructure which you set here, and then data sets experiments are nothing but your runs which you are having for the models. Pipelines are nothing but the flow which we created through designer is your ML pipeline, and the models which you publish gets featured here in the models section, and the endpoints are your endpoints of the application which can be used as web services. Okay, yeah, that's all from my end. Any other questions or comments anybody have?
I have a comment. I mean, I've never dove into the Azure Machine Learning Studio, so thank you for sharing. That was really cool to see that.
Sure, thanks a lot. Yeah, the intention of the call is to just browse through the UI of it and just showcase what the possibilities or what features we have. Not necessarily discussing what the machine learning itself we have. Yeah, so thanks.
This is Gary's out here.